So yeah, welcome. Yeah, perfect order of presentations now. So Jan explained a lot about the micro LEDs, and I will follow up with some post presses now and show how we enable hopefully the micro LED display manufacturing. I'm mainly focusing on our deep UV laser solutions. I have one different example, and yeah, we call it always now our technology is a future-proof approach, and I will show you why. So, so we are the equipment manufacturer for display or all kind of displays, and from this perspective, we are looking to the market, and we see the micro LEDs now, yeah, starting in small application, like we discussed AR. I think it's the best light engine solution today, but we are more focusing on larger areas because yeah, the larger square or the more square meters we have to or our customers have to produce, the more equipment we can sell. But we learned over the last years now that yeah, who is your stakeholders or key players in this market. And I'm always explaining now that, like you have seen, we need a good EPI. So we need a good compound semi micro LED. They have to get small. They have to get high brightness. But so if we go to larger formats, we need also display makers, and that means also we need display equipment. And this is our play where we are yeah, familiar with, and we are known in the market for laser equipment in mainly, of course, in OLED now, but we have already a very good footprint at this early stage in micro LED display, let's say pilot lines and manufacturing. And yeah, it's important when you talk to the big ones that you can offer 24/7 service and machines that run yeah, even 24/7. So that said, our main focus is on a little bit on larger formats, because yeah, this is the main market where we think we can sell our laser-based equipment. And of course, what we see is that the new technology, like also the OLED technology now or in the past, there are a couple of laser processes that are mandatory, or at least helping to make a good display. So here is my overview and the process chain, and I think the different to OLED is that we have different fabs. So the EPI could be completely separated from like the display fab, where we make the final displays, or the display makers make their final displays. They can purchase or buy an EPI wafer or already a processed wafer, what we call the laser lift off. So getting the micro LEDs pre-qualified on a temporary carrier. And the third part is also that what we see for larger formats is the backplane technology. So when you walk through shows and see everything like automotive size displays, almost all are made on LTPS backplane, and this is also our main core market. So below you see the 4 different core processes where we are playing with our lasers today. It's the lift off to release the micro LED from the EPI wafer, and then the mass transfer. And yeah, sometimes you need a repair, so we want to address a single micro LED to remove it or refill it. And nowadays, this 4th process is not a UV process, but laser-assisted bonding. So after the transfer and after the repair, the final bonding step can also be done by a diode laser at a different wavelength. So I will have a short example. So what I said, backplanes are our daily business. So we have more than a decade or more decades of mass production, and it's always what we call the de facto is a standard for all OLED displays today. And as I said, if you go to shows, you will see TV or TVs or automotive or larger micro LED displays, you will also see the LTPS. So next generation backplanes can be used almost like the OLED displays, and we also see that we have to, or the new fabs are going to larger formats, not now to generation 8.6 to keep the economy of scale when you go to larger displays. And yeah, what we see is that almost every display maker in the world has already access to the LTPS backplane. So they can use more or less their standard equipment, and yeah, with little modification, they can make backplanes for micro LEDs as well. So this is the first step going to LLO, and also we are focusing mainly on gallium nitride on sapphire, like Jan said also. And this is a very traditional process now, the liftoff, due to material combination and due to the fact that we want to absorb in the first nanometers of the gallium nitride buffer layer. The short UV wavelengths is mandatory to get a damage-free laser liftoff or between the gallium nitride layers and the sapphire wafers. And yeah, so we started many years ago, and what you see here on the right hand side today, looking a little bit on the productivity, you see with that, of course, there are, let's say, solutions available where you use a small single spot to do the entire wafer liftoff. So here we are focusing or targeting more the less than an hour per wafer. Then we offer a little bit faster processing, so like small square spots with our laser systems, where we talk about minutes. And then the fastest solution, we can also go up to a line beam system to cover a full 6 or 8 inch wafer and process this in a few seconds. So all this is mandatory with very deep UV wavelengths. So in this case, we are using our 248 nanometer lasers. Yeah, as said, the most challenging is the transfer. And there are many different, so as Jan said, no golden standard. So we are working on this, but you see that we with all the customers we are working today, they have different ways how to make a micro LED display, how to make the transfer. And there are ways to, or customers are interested to go directly from the epi wafer, transferring the micro LEDs selective to a backplane. Some are getting already micro LEDs on a temporary carrier and shooting them to a backplane, or just preparing the what we call a second donor. So making the RGB on a donor template, and then it can be done by mechanical bonding to make an RGB displays. So there are many ways. We see all of them in the industry already, and yeah, so we also try to help customers to find a golden standard like we see in OLED today. The good news is we have solutions to offer all the different approaches, and our equipment is capable. That's again why we say future-proof. Here you see we learned from 5x5 micron. This is a target, and also Jan mentioned this already. So this is we are looking. The larger micro LEDs are easy to transfer for us, but we know that they have to get smaller. The material has to, material cost has to come down to make the micro LED displays cost comparable. And the question is, will it ever happen? So are we getting the efficiency, the EQE of the small micro LEDs to make them industrial available? And we are looking onto 5x5 micron now to see how our solution can transfer these 5x5 microns. And as you see here, they are already perfectly transferred. So again, future-proof. The laser mass transfer we are using in our setup goes beyond the current limits and can handle already 5 by 5 microns. Yeah, that's it. So the backplane, now we have done the laser liftoff and mass transfer, and a little outlook what is next. So after, we hope that we don't need too much repair, and now more and more interest we see in laser assisted bonding. So after the final transfer, the micro LEDs are sticky or sticked on the backplane on bumps, but not really bonded. And here there is a process called laser assisted bonding. So this is a thermal process. We are using a 980 nanometer wavelength diode laser. Also, we can create, as you see on the lower left, lines or square beams, and with this we can very precise heat up or the micro LEDs and do the final bonding process to the backplane. The laser assisted bonding also is not new. It's used already in microelectronics. So it's let's say an industrial process, but now we are adapting this to micro LEDs, and yeah, that's where we see a lot of interest now after the transfer is already solved. Again, our customers have the choice. So we are usually an OEM supplier. We offer lasers, deep UV lasers in different power classes. We are having a big team designing different kind of optics. And for the micro LED, we decided to go one step further. And because of the complexity of the transfer, we are working to, or we have a tool available to make all the good results and the precise handling. So this is what we offer to our customers: repair, mass transfer, laser liftoff. Laser assisted bonding is the fourth new process. And yeah, that's it. So my summary: again, you need a good compound semi company to make a good micro LED. Then you need a display maker and also some display equipment to make a good micro LED display. Yeah, they must get small. Lasers are known for precise processing. That's why we are in the market, and that's why we are looking into this in more detail. And the second is that we have seen that lasers are essential to do the micro LED or making micro LED manufacturing available. It's a future-proof process, and we know how to scale. We have done this for the OLED industry, started at the small generation displays, and today we are scaled up to large Gen 8 panels for OLED. So we can grow with the customer needs in the display fabs. That's what we see. The question is, will it get real? At least we are on a pretty good path, and we are ready. Let's say we're just waiting that others follow us. Thank you.